Good evening. Welcome to me catching up to actually doing stuff. Hey there, Finboy. Barcode. Wow, thank you, FGs. Are you about to offer me these great deals on getting more followers and subscribers too? I have this weird feeling that streaming programming isn't the way to do it. For some weird reason. Anyway, got about 3 days to catch up on. Didn't have time. I mean, Friday I had to go to work and I didn't want to get out of bed because I slept like shit. Saturday I was in bed till about 3 because I was awake until about 6. And, well, today's today. So that's why we're going to do 3 days in one go. I'm not sure if I'll go back and look at everyone's code for the previous days. Depends on how fast the days goes. I've no clue. I haven't taken a look at the channel much, of course, because it's all spoilered anyway. I did see some people write about lines like 500 lines of code programs, which if they're coding in Fortran doesn't mean much. But yeah, I will see. In theory, I've got the rest of the evening. I would like to do something else, but that's not, time crucial. Let's just hop into it. So, riding a camel across a desert island when you spot a sandstorm quickly approaching. She disappears before your eyes. She's just running to ghost all along. 8 and 9 are easy. Day 10 will take some time unless you're boring. We'll see. I think after she rewrote his solution a few times, right? No, we'll see. It's full of documents. You're puzzling about how to navigate the desert. At least you're pretty sure they are. One of the documents contain a list of left-right instructions. The rest documents can describe a network of labeled nodes. Navigate the network. After examining the map for each 2 nodes, stick out A and ZZ. Feel like A is where you're right now. You have to follow the left-right instructions to reach CCC. So look at the next element based on the next. Go right, but using the right element, CCC. Choose the left element. Of course, you might not find set away if you run out of left-rights. Repeat the whole set of instructions. This feels like there's going to be some weird twist. Boom, bum, ba-dum, bum, bum, bum. Standards, input rating stuff, nothing special. Interesting that it actually did all that already. Did it grab that from a previous day? Because that is actually what I wanted to do. Time to go back into the vault to learn Nitrous folder naming structure? What? What do I want to do here? Oh, I see. I mean, oh no. You know my first name? How could you ever figure this out? We want to do stuff here as well. Imagine not doing all your parsing in the first line. I wonder if this works. What? Could you? Thank you. That's what I thought. DHP Nitro. No, I was thinking about actually switching to Dr. Nitro, but we'll see. Shouldn't this go to prof? Yeah, but I'm not a professor yet. That's definitely not true. Oh no, because it's gonna be I'd have to do it like this, which is disgusting, but you know. Yeah. There we go. Why do I get AAABBB? It's using it in your dig. No, actually, that would be true. Yeah, let's just do this a little. Do this like this, and stop being a bit stupid here. It's writing readable code. Shh. Come on. Don't come at me with facts and logic. No, I should do. Nah, I mean, I could strip it again, but it doesn't really matter. I mean, this will have aura, but you can just trivially do it some other way. Can't do one letters at work. Yeah, I know it does. That's very unfortunate. I mean, I wouldn't write code like that properly either. I don't use regex that much though. I've used it like once this year. Path and n, print p. This should just be single line, right? Yeah. What the hell? What? Oh yeah, of course. N is a, yeah. N is a string. There we go. Do I want anything here? Do I even care? I mean, no, it's just fine. I'm thinking there's a way to actually like do this in a slightly more intelligent way. I mean, I'll probably do something like paths. No, I can't do this. Start, end equals p dot split. I want to use whale operator, but I can't. And it'll be something like paths s equals E dot split space comma space Yep, there we go. I mean, I'm also not thinking very hard about this. Alright, so there we go. Why is it giving me these code completion hints? This is actually very new. Is that like the... I don't like this. Full line completion runs locally. Huh. Why would I say if current? No. Actually... Yeah. So I can do like... There'll be directions. What do we start on? Actually, no. So D would be DS, index, steps, modulus, len DS. Actually, how does that work if I have like... Yeah, just goes out of range. Just quickly test this. Oh no, so it already... Yeah, I was thinking for a second I would have a /n at the end. So... Yeah, whatever. Sounds good. I want to press tab to like have it finish the current word, but not everything else. Why would you do this? This is so weird. I don't like it. Sorry, tuple. I mean, left is 0, right is 1. Could you, So from AA... We go right, so we go... to, paths. A CCC, right? Yeah. CCC, we go to... Wait. Oh, 2 steps. Yeah. Okay. But then current should be GGG. Okay. What? Oh no, I am stupid. No, wait. What? Oh yeah, I don't increment steps. Oh, what the hell? What am I typing, man? It's difficult. I'm very used to using that as an enumerator. Yeah, there we go. That's good to me. Right, that is the right answer. It sounds like upon you aren't any closer to escaping the wasteland. It's going to take significantly more steps. What maps is for ghosts? So it's a curious fact, the number of nodes with the number of A is equal to the number of ending Z. So every node starts with A, follow all of the paths at the same time until they all simultaneously end up with nodes that end with Z. Okay. So let me just already put this into the test inputs. Okay, you are at 1A and 1 with... Okay. So... Okay. So we start at... is if n dot ends. Why would you hit current? There we go. Why B? It's such a weird thing to do. Okay, so current. It's all of these, yeah. Yeah. Six. It never ends. Let's let it run for a little while. Because it is... Sometimes away from both nodes, repeats buttons to all the nodes you're currently on and we'll see if only some of the nodes that act like another you continue as normal. Okay, let's see. Before you're only on nodes that end with Z. Ends with A, if all ends with Z for ending current, so step current equals path C, 0 if D is L. Yeah, let's take the left option. That sounds alright. So why are you not working? Yeah, here we go. Let's see, so where's current? Oh yeah, I mean, I assume that, let's see, yeah, it's end with, right? I'm not stupid. End in Z, yeah. I mean, you're just doing it simultaneously. This shouldn't really be... Wait, R, oh yeah, no, yeah. I mean... I have no clue... Oh, it's probably going to be cycles, right? Yeah. And then it's LCM. I'm stupid. If... God damn it. For C... What do I do? LCM independent steps and C dot remove, oh no, current dot remove C. Haha. Yes, why would it be end with and not ends with? And then print maths.lcm. Why would you do map in LCM? Let's not do math. It's too high. Seems a bit high as well. Let's see, while... Zero, 1, nice. Because I need to remove the knots. Why would I test my test input again? That's so weird. Why would I do that? Gives me 2. What? Okay. Print steps. Could you print L, please? 1 and 2. Because I need to do +1. There we go. That's the right answer. Probably pathetic leaderboard. Hey there, Marvin. Day 8. How the fuck am I the fastest? The fuck's wrong with you people? I mean, that was going to be my next step, to basically do that. Alright. Also, I should have convinced you to brute force after all. No, I mean, that wouldn't have been a smart idea. What did I want to say? You can actually calculate your own LCM fairly easily by just getting all the prime components. And then doing a set on that and multiplying them all together. I think that works. I'm not super sure. It can't be that the cycle isn't complete, that it starts some of the way in. Oh yeah, that's true. Because then you would just get a prime thing. No, that's true. No, you're right. You're right, Hamster. That it's possible the cycle isn't complete. You would basically have to. I mean, I'm pretty sure if that would be the case, it would be basically impossible to do this without brute forcing, because you could be in any of like these positions, and you wouldn't know where. We would loop at the second cycle, but neither of us looked at the data, so yeah. Cycle at the second loop. Oh, I see what you mean. Nothing else would be a nice pattern. I mean, oh, the Chinese remainder theorem. Oh yeah, I remember that one. Oh god, I hated that that puzzle. Let's see. Anything else I can really improve here? Can bring back part 1. That's actually a good point. I mean, part 1 would simply be having one that's just because one of these. So it would be like this, like AAA equals 0 equals none. Oh, how would you get the one? Oh, it'd be like whatever, like current dot index a if current dot index c equals a. Ah, damn, you're right. Why wouldn't you let me fail? And just let me see the 6 here and go, that makes sense. This is a completely another before this 1.5, the offset of period are equal. Ah, that's rough. How would you have to... How would you... That's fair. Isn't current gonna put it at the end? No, it's at the start, actually. Oh, this is... No, yeah, if it's a 0th entry... Oh yeah, no, because then it'll get overridden. Yeah, overwritten. Oh, how it's 0? So this should be true. What are steps? 0. What? Oh, yeah. I'm putting it in the wrong spot. I need to put it here. My bad. Yeah, no, it's the right answer. I'm just being stupid. This is what I'm going for, though? Was it 17? Was it 1741? Yeah, 1741. I mean, technically I could just increment steps here. There we go. What? Oh, I need to do it here, of course. Yeah. All right. That is that done. This is fine. I mean, you could do... Nah, you could make this one lineup that's horrible. Yeah, I know. Anything interesting here? That already puts me back on 3rd on the leaderboard. Alright, let's go to day 9. Just make the test the input files already. You ride the camel through the sandstorm and stop where the Ghostman told you to stop. The sandstorm is either subsiding you or standing on an oasis. Ghost got some water stretch your neck. If you look up, there will be yet another giant floating island. This one made from metal. This would be the parts to fix the sound machines come from. There's even a hang glider partially buried in the sand here. Once the sun rises in the heat of the sun, I will use an hot air to get all the way up there. While you wait for the sun to rise, you admire the oasis hidden in the middle of the desert island. It must have a delicate ecosystem. You might as well take some ecological readings while you wait. Maybe you can report any environmental instabilities you find to someone so the oasis can be around for the next sandstorm or traveler. You pull out your your handy OAS Oasis. Oh, nice. And analyze your surroundings. The Oasis produces a report of many values and how they are changing over time. Each line in the report contains the history of a single value. To best protect the Oasis, your environments will include the prediction of the next value in each history. To do this, start by making a next sequence of all the difference in each step in your history. If that sequence is not all zeros, repeat this process, using the sequence you generate as the input sequence. As all the values in your latest sequence are 0, you can extrapolate what the next value of the original history should be. So just find the derivatives. There's one for your number. Yeah, that makes sense. Okay. What do we actually need to find? Maybe I should finish reading that first. Adding a 0 to the end of your list of zeros because the zeros represent difference between two values above them. So they place on every sequence above it. Yeah. From the bottom up, any speed result incremented by 3. So what's the next value here? The first history is 18. Alright. Add them together. Alright. So these are all polynomials. Wait, are they? No, they're no. I mean, no, they are exponential functions, I think. Sorry, just normal polynomials. I think there's a way you can cheese it a bit, but what was it again? Open. Why would you do that? That's not even correct syntax. I wonder if it even takes in the name of the file as like a as a thing. Oh yeah. Why are you thinking so hard? No, because I lose track of what I do before. Like, this is super easy to do, but I'm just... Because in theory, we just get a polynomial every single time. And I can just do... Because you get some base value. 1 second. Charge my watch. So any next value is um, oh. Wait, what? Oh yeah. $14. Okay. Do. Too high? What? Sloppy. Very sloppy. Oh yeah, you didn't see me fix it. It's still too high. Interesting. What am I doing wrong here? Is this some sort of edge case that I don't get right? Oh, actually, why don't you print and also just print V, so then I can go over if I think some of these might make any sense. Because I know one of those I could figure out myself, basically. What was it? Like 119? I mean, I could go through these individually, but I assume that it's fairly robust, like, you know, while this... Oh, Christ. I'm stupid. Why am I like this? It could be -3, 3, -3, 3, stuff like that, whatever. It should be, all of them should be 0. I mean, I know what to do, but because I can just do because all just takes an array, like, you know, it's not very complicated, but oh, actually, can it is like none? Because like all, you know, all need to be true. I mean, I wonder, like, is there a way to check if they're all false? You can't just negate this. Oh no, I can do like any. See, that just gives me 81. Because then this is like... No, because then... Yeah, no. That doesn't work. No, because I'm doing this in a really clunky way. And I want to see if I can do it in a good way. Because I just need to see if this is equal to 0. Which is basically like this. But this doesn't work with the whale operator that I'm using. Import solution looking. What is T? False, 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 false. Oh yeah, no, so that's a terrible idea, because then you get, that's actually false, because we don't want this, because now it's doing this, but I need this. Can't wait for it just to be the same answer. It is slightly different. That's the right answer. Even more history. So we say it's really backwards as well, right? Repeat the process of finding difference until the sequence is 0, then rather than adding 0 to the end, filling all you need to add 0 to the beginning of your sequence. Fill in the new first values. What's some of the X related values? Hmm. Oh, because it's this one minus this, right? Let me think. 0, yeah, that's 2, that'll be... No, because this is plus plus plus, we need to do minus minus minus. Ugh. Is it 6? I don't think it's 6. 2, no. Why are you 6? Can you also print like last fee? Because it's 15, so it's like 302. Oh yeah, because it should be like... Am I doing this right? This really isn't all that difficult. Shouldn't it still just be sum? No, because it's like, it's 0. It's like 3 minus 0 minus 2. Oh, but the first value should just be positive. It should be 10. Yeah, I see. No, wait, because that is what we're doing, right? (10 minus 3 minus, yeah, which should be, what the hell? 3 minus 0 minus 2 is 6? What? I am very confused here. Here we go. That's 1. What? Okay. 302. The fuck do you do? I am very confused here. Okay, whatever. This should just work. Like, why does it not work? Oh. What? Shouldn't that be? Cause you should do 1 minus 2. What am I going crazy for? So what do you produce? 10, okay, and then subtract. It's 5. So why don't you... Why do you do 0? Oh, no, because... What? Yeah, no, of course, because it's not doing... Because last V... Why do I keep typing full stops? So I hate this quite a bit. So you are 5. Can we like just put you like here? So -3, -2, and 0 for the second history. Okay, so why is it producing -5? So right here, right? Okay. So what do you then produce? Last V. Okay. 2, 6. Yeah. So it should be 1. Yeah, 1 minus 2 minus 1. What's going wrong here in my logic? I hate that this is probably also ruining the leaderboards for Deltas, but whatever. Why does it work for this? Oh, it's because probably the 2 and the +2 and -2 cancel each other out or something. Because this should be 1. Yeah, -2, -1 makes no sense. Because it should be just this one. -1 is... So yeah, so we actually... I see we alternate. So we always subtract the value, right? Oh yeah, no, this is because I did a fairly sloppy implementation. Because it should be like 1 -2 -1, but like with brackets in there. So you go from the back. So you do 0 -1. And then you do, yeah, so 0, and you do minus that. Ugh. I don't know, like, I know exactly what's going on. I'm just very confused. Ugh. Like, I know exactly what to do, but for some reason my brain just isn't working properly. Because, like, I know what I have to do, I just don't want to do it. No, you don't know. I know exactly what to do because it'll be. You would have wrote 1 line of code if you knew. Ah, but my mind can't think of it. What's the? It should be like v 0. This I already think is a cleaner setup in general. Yeah, we're still getting the same issue, and I know. Because I was thinking, okay, but then this should be like. What? What are you on about? Okay, fuck it. For some reason, my brain just doesn't want to work at the moment. Why is my brain not working at the moment? Ugh. This is very incorrect, I suspect. Oh, it is correct. It's this. I hate this. Why? Why? Why would... wait, no leaderboard. I know it's gonna be pathetic. Hate it, hate it, hate it, hate it. Yeah, terrible. 17 minutes. There goes my score. Why? Nah, I'm just staring at it. No, what? No, I need to turn on the code completion. It's utter ass. I genuinely hate it. Can I, like, turn this off? Code completion. Thank you. Oh, yeah. In place operation. What are you on about? I'm actually not entirely sure either. I mean, because it flips which one you're subtracting, because I mean, oh yeah, I'm also reusing T, so I can't, fuck it, I can't use that, of course. What are you on about? Oh yeah, here, well, whatever, don't need this anymore. What pattern are you on about? Okay, I need to take a goddamn look to see what the hell you're on about. Oh yeah, but you build your... I mean, I'm taking a quick look at your code. You're building your sequence in a very different way. You're keeping a running tally, which I'm not doing. Oh, I see what you mean. Oh, this means I won't have my working version here. That's terrible. Okay, now there we go. No, I mean, no, I'm like... Oh, what do you want about now? Yeah, but that's just not the way that mine works. So that's the issue. Just reverse your input. Oh, the inputs. Yeah, I see what you mean. I see what you mean. No, I was thinking that you were talking about reversing this list and not this list. So of course my confusion arises there. You know, fucking wonder. You talk about reversing a different element than what I'm working with. No, shut up. I'm not wrong here. You even saw my solution. Yeah, but it's like it's very different. So of course I didn't. Oh no, I didn't see you were, because I was thinking that like, because plus equal for me happens here, and that's a different value to what you have. So no, of course I. Do you think I actually read what you're coding? Come on now. I was just seeing if you had like a single line, like what I'm doing here, but like this. But of course you're not, because you're doing it in a different way. So no, it's not that easy. Well, I mean, whatever. It kind of is. Because I would basically just do... like this. Then you have the same thing. Which ironically is more work. Can I do this at one go? Yeah, because... Oh yeah, I mean, but that same thing I have here, because this is basically a function, and then I just reverse the input. Like, it works. But that's just not the way I coded my solution. I mean, it is... If I had realized this, yeah, because this is what I had originally, right? Yeah. And then I can just make this v equals... I mean, it's sloppy. I mean, it definitely could have been done. Could have done this better, way faster. I mean, the thing that I coded would work just fine, but because when you're doing it in the reverse, you have to alternate which one you add and which one you subtract. And I was thinking about writing a quick reduce function to like do plus minus alternating, but that also just was clunky. So my solution, my thought process was perfectly fine, but this is indeed the better solution. We'll see. All right, let's do day 10. Ugh. Terrible 6 points. That dropped me way behind in the delta. In theory, I should still be ahead, though. I just need to get 4 points, which is fine. But, well, we'll see. Use the hang glider to ride the hot air from this all the way to the floating metal line. It's personally cold, there's definitely aren't any thermals to glide on, so leave your hang glider behind. Any people or animals, you can find a signpost labeled hot springs, pointing in a seemingly constant direction. We can find some at the hot springs and see ask them where the desert machine parts are made. Everything's made out of the metal. The walls, the air. It's densely packed with pipes, because it's still semi-metallic, so we can switch to the little service pipes you can see. Oh god, it's probably pathfinding, isn't it? Yeah. Let's see, slightly more complex main loop. Okay. Tell that loops that's further from the starting position, because the animal is in the... Okay. Complex loop. Oh, great. I'm just making the files. Alright. Alright, I'm gonna... S and F? Nice group connecting south and east, okay. So what we want to do is we want to go through this and just discard anything that doesn't connect on either side. And then we just loop that until nothing changes. I mean, it doesn't even matter. We can just go to start, and then just spread out from there. And then we keep going. Right, so... Do we do depth or do we do breadth for a search? Alright. Alright, considering I don't actually care about anything else, I'm going to take this slightly simpler example. Because I will only ever go to start and from there go. On. Right, so let's do just print fields. All right, so S. Shouldn't this oh, yeah. Shouldn't be like there was a flatten one. It was like a really stupid way to flatten a list. Shouldn't this just work? Or is it like seeing this as 0, 0? What if I do it like this? What are you complaining about now? Boring. No, because I'm trying to do it in stupid ways. It's like very easy. What? Yeah, no, I know. It's no, because I'm trying to like reduce this again. Why does this keep these? Shouldn't be A if A is not. Yeah, there we go. Oh, yeah, it should be. Yeah. Okay. Perfect. Adjacency is just -1, comma. Oh. If only I had written a pathfinding one already. Yeah, I'm writing the same thing again. Would have been funny to not notice. So what do I do now? Now I can just get all the adjacencies. I find the point that is furthest away. So this will be all the nodes that we're going to start on. Oh god, now I have to do some kind of horrible adjacency checking. Oh god, right. Oh, this is gonna be ass. Oh my god. Do I want to do what I think I want to do? I think I do. All right, baby. People, this is gonna be terrible. But live with it. I mean, I assume this is all the ones we have. LJ7F. All right, so this is the connections. So this one goes to the right, which is 1, and to the top, which is going to be 1j, which is an imaginary number. Same here, it goes to the left, which is minus 1j. And then it goes to the top. Left, which is minus 1, and then top, which is 1j. And 1i. But the reason for this is because if I want to see if 2 can connect to each other, I basically see if is there overlap between, so say I want to see if a pipe connects to a dash, for example. Actually, let me just finish this real quick. So this goes -1, -1 j, and this one goes from 1 to -1 j. Oh, using imaginary numbers is very, very common. I think I've used it before in my implementations for pathfinding, because you can do rotation very well, because a left rotation is always multiplying by -1, and a right rotation is always multiplying by a left rotation is always multiplying by -1j, and a right rotation is always multiplying by 1j. And that allows for to keep track of like orientation very, very nicely. But here it'll also allow me to do some fairly fine, nice things. So what I can do here is say I've got A equals bar, B equals dash. Then I can do set I might want to make these sets actually. That's gonna be a massive fucking pain to change. Why did I not just do this right the first time? Ah. Yeah. Do I have to really write fucking set here? Fine. Wait. Oh, yeah, I forgot about that actually. That's what that was again. Exactly, I'm glad you understand there, C-Fusion. So now it's 0, which means that these two don't connect. Sorry, I need to do -1 times this. Oh, bollocks. Do we need to make them numpy arrays? Can I do like an... I really don't have to go to numpy. I could also just make a simple second one of like what does it connect to, which would also be fairly easy. Fuck it. Numpy's rejects of arrays. What? I don't like that that definition at all. Alright, so now what I can do this. Oh, okay, like... So if, say, do I want to say if an L connects to a 7, which it should, it'll give me oh, but of course I need a... Is it from rejects? I don't want to write lots of shitty ifs, and then I need to do an AND with the actual direction we're going. So say I want to go to the right. Then it'll work. Wait a minute. So... Wait a minute, is this correct actually? Oh yeah, so... A better example would be this in a dash. So say we're coming from... We're gonna go right, that works. Let's say we're gonna go left, which would be -1, we would get nothing. And this way we can actually check this. So now I just need to rewrite this as well. Didn't they do real and imaginary already in basic Python? Ugh. I guess we're doing NumPy anyway. I don't like it. Alright, just don't make errors. It's fairly easy. Perfect. What are you complaining about? I love this. It's so horrible. Next node. What are you complaining about, my friend? Oh, because you're still afloat, yeah. I love how terrible this is. Imagine like writing maintainable code. Perfect. Alright, what do we want to do then? We want to just do like it's terrible when it works. It's still oh yeah, but it's like it's you can get satisfaction from the fact that you get something terrible that does work. Do. Right, next nodes. Hey there, Moreno. Indeed, something a little different. Cheers to Moreno. There we go. What are you complaining about, buddy? Curse symbol is not. Oh, yeah. What? No, of course it's not defined. That's the whole point. Oh, because it should be chord, not curse symbol. Whoopsie. What's going on? When's a prototype for operand? Oh yeah, because what's going on? Key error. Dot. Oh yeah, because it should be next symbol, not next node. Alright, so next nodes. 0. Wonderful. Let's see what you do. So next symbol. Oh yeah, I should actually. I appreciate it. This needs to get inbounds checking. Or I can make field like a default dict, which might be easier. Or I could just do if. What are you writing? I'm doing a programming puzzle. Real is X, so that should be field 0 and image. Oh, that too. There we go. Where are we now? Next symbol should be. Did it already? Next symbol not defined? Oh, because it's out of bounds. Because we started. Wait. Minus 2J? Oh no, it should be. I did that the wrong way around. No, because yeah, the directions are fucked. There we go, because we need to count from the bottom, so it should be 0. It should still be 2, but now it should be 2J. You should be nodes. Wait, so chord 3J. Because you should be 5. Yeah, minus 1. 0, 1, 2. There we go. 2J, 2J. D chord is 1. 1 plus 2J. It's all good. Next symbol is J. Because it's this one. Yeah, I'm still a marshal at Sandford. Just for fun, yeah. Just for Advent of Code. Last time I was there was a few weeks ago. During the Sandford, the Hark. I was there last. Alright, good. Step through it again. Should be dot. We should not get a next node. Good. And 3J. Next symbol should be F. Just what? So 3J should be this one. Should be a pipe. Yeah, current symbol's F. Next symbol's 7. What? Wait, yeah, D-chord, so 2J. Wait, which am I counting? It should be, no, I'm counting. Yeah, I'll probably see you there next season. Now 1J should be up. Should be up 1. So that should, okay, yeah, something's going wrong here. What the hell else going on? So dot should be 1J. Yeah. Because this one, I did it the wrong way around. That's annoying. Ah, that's pretty nice. Yeah, I see your photos float by every once in a while. There we go. Oh, this is okay. And now I'm just hurting myself by making mistakes. The reason why is because I don't want to have to rewrite these two with the other rotations. But I think we should. That makes everything a lot easier. Alright, because then you don't connect to 1J, you connect to minus 1J. Okay, it's actually not that much work. Because you don't matter, you go both. Yeah. There we go, that was fairly easy. It's pretty stupid of me anyway to try and do it the other way around. Alright, so 2J, current symbol is F. What the hell? Oh no, this I do need to keep. Wait, no, because it should be 0, 1, 2. Oh, did I flip these around? Yeah. Jesus Christ. Actual garbage coder. Yeah, S. J, because the first one we take a look at is the one to the... Wait. One plus 2J. Oh, because it's skipped over it, of course, yeah, because we don't actually do it. To the right, and then the next one should be going one up, which should be a full stop. Why you're breaking? Key error S. Oh yeah. If funny that I didn't even actually notice that this would have should have given an error, by the way. Right. pipe. Because there should only be 2 connections. Right. And now distances. Alright, cheers to Marina. Right, so this will just traverse every single node next. But it'll keep going in loops. It'll keep going forever. Because there's a difference between knowing that there's a loop. Because basically, if a value is already in there, we don't want to recheck it. So how do we know we've done that? Okay, so first things first, there is no way for this to actually be relevant. This will never happen. Because there's only 2 ways we can actually go. It'll just not be in there. So basically, if it's already in there, we found the loop, we've met it. And we should do that at exactly the same time. So basically, if next node in distances, we know we're done. And we have to break out of everything. Well, fuck it. Just do done equals false. There will only ever be 2 ones, so what? Distances, no, it's 0. Yeah. Because it should print the distance, so it should, do a few iterations. Yeah, I know it's black. Whatever, let me just grab it on my end. Because what it should do is go like 0, 1, 2, 3, 4, 5, yeah. We can actually make this a default text. Let's do that first. This will make it easier for me to print it in a bit. If I want to. I mean, might as well write it, because, why not? Didn't I write something like this for, 2020, 2015? Basically just wrote it? Kind of. Oh, yeah, sorry, it should just be X, Y. Nice. Oh, yeah, of course, because it's going to be... don't want it to actually be a default dict. Because it'll just... Hey. Shouldn't states be like a few of them? Yeah. So... What is... 2310. Oh, yeah. There we go. Because it only maps this little area, these 4 characters. But hell yeah. Oh yeah, no, of course, because well, duh, it's gonna be in there. We basically need to check if it's not regressing. Because it'll just keep looping forever now. How do we know we're done? If the value that we're in, we just never actually want to, we don't care about going back, but I can't be arsed to actually code in. Oh, actually, no, that's easy. No, wait. So what I can do is very easy to do, like if next node not in distances and oh. Okay, well, we'll never be done, of course. Why? While stop. Why? What's going on? Okay. Okay, wait, what the hell's going on? Okay. SNO, what do we have? What's our chord? Chord is 2J, so we're still in the first loop. Oh, Jesus Christ. Right, so now we're at 1 plus 2J. Which is this one, should be J, yeah. So the next one we go to should be so what's the next symbol? It's dot. So we skip it. F. So it's one on top, so this should be added, which is 1 plus 1J. It is. Good. And then we skip over S, which is great. Then we go to the pipe. And the pipe connects to an F, but we don't actually add it. And the next one should be an L, which we do add. Ah, but we never refresh next nodes. That's why. There we go, because I'm stupid. There we go. And what do you then want to know, buddy? How many steps long does it take to get from the start to the first farthest? Okay. I'm a bit worried about this. See, the issue here is that it feels for me that these always like take forever to execute. Like it's super easy to get stuck in like some infinite loop. We'll see. Richt. Maybe we don't print the. Oh yeah. Print max distances dot values. Yeah. All right. Maybe that's within the area enclosed. Similar to those words we're saying, you still got how many tiles are contained within the loop. Oh, fuck no. Wait, what? Maybe it's within the area. To determine whether it's even worth taking the time to how many tiles are contained within a loop, for example. Yeah. Goes merely 4 tiles. Ah, inner, outer, because this can connect to the outside. Yeah, so this is inner because it's actually enclosed. Is a much larger example. Okay. How many lines are enclosed by the loop? So what? Does part 1 even fucking matters? Okay, how do you even fucking determine what's in and outside the loop? Like it's a puzzle. Oh, yeah, really? Nah, I never could have guessed. So you basically want to do some sort of pathfinding. So one of the things that I'm thinking of, you would expand. You would basically do some sort of. You would expand your entire grid by one in every direction to basically model the in-between paths. And these are always just going to be empty space. You can also model this by having like the half paths as adjacencies. It's actually fairly easy to implement. And then you just do pathfinding to the outside. So from here, you would basically have this as your starting position. You would do any spot. Doesn't matter. You basically, can you reach the outside? I've done this before for another day. I'm pretty sure I'm just gonna not care about delta. And I'm curious, what are the deltas for today? I'm pretty impressed it only took you an hour. So what you do then is you do pathfinding, and the moment you reach an outside, you're free. So here, you would basically do a flood fill, and this would all fill up. But you would only count integer tiles, because these would all be half integers. So what do we do here? Okay, I'm gonna commit this, because I'm gonna fuck up day 10 hard now. Alright, downloads. No, repos. 2023. D8, 9, 10, P1. This way I can fall back to the old version. Alright, time to commit some war crimes, baby. So what we're going to do first is we're going to actually add adjacencies to any half integer. So this will be 0.5, 0.5, 0.5, 0.5. And what we do here is we do if so current symbol. So what we could do here is we add like an intermediate, which is be like a question mark, and this has connections everywhere. Just like we can actually do current symbols like S. Actually, no. Let's it's fine actually. If, because then you can go intermediate, you can go all directions. If image chord dot is integer. Can you like chord dot is integer? Does that work? So let's do 1j dot is complex object has no. Okay, so then we just do 1j dot is integer from numpy import num real match true, yeah. And then we do 1.5j false, and let's say do 1 plus this false. Yeah, perfect. Image and else question mark. Oh, else else. Do 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 do. Next node. Yeah. Oh wait, what am I doing here? Okay, but distances are still kind of. Oh bloody hell. So is this even completely irrelevant? No, because we have one loop. And is things inside the loop they're no. I need to take a look at the instructions actually. Okay, so we have all these tiles. But wait a minute. Is it the loop? Wait. By the loop, so nothing else matters. By loop mark with I. Okay, so I'm taking a look at the instructions, and what I'm kind of confused by is like, is everything here part of the loop? So we first need to go like, no. Fuck. Because here are these examples. This is the whole loop. But of course there's other here. Yeah, okay. Any tile that isn't part of the main loop can count as being enclosed by the loop. Wait, no. So that includes, yeah, many bits of junk pipe laying around. Yeah, so everything inside. So it's either dots or... Okay, so we kind of want to like... But that's fine, because we know what's part of the main loop. That's anything that's in distances, so that's fine. So then we go and... We go for anything within the grid that isn't... So this basically, we can give it a starting coordinate. Okay, we wanna definitely do mnemonics here, because that is actually side. But we also have things that are part of the loop, like the loop itself. Oh Jesus Christ, this is making my head hurt, man. Right, let's grab this simple example. I dislike that it actually just grab this one, because this'll be fine. Right. Yeah, but this is gonna fuck up my original logic as well, jeez. Oh my god. My head is starting to hurt. Alright, I need to grab my original code real quick. Oh, you were not even seeing any of that? Alright. There isn't anything on my GitHub that would be immediately bad, so it's not super worrying, but it's a little clunky. Okay. Here we go. And it would be def p1. Because what I want from here is the distances field. And the reason why is because in here I can just define different adjacencies. Because here my adjacencies will just be the whole integer values. -1 and 1. And then we can just, yeah, this is the old part. Because we're gonna want to rewrite a lot of this code. So what I want to do first is basically do... just Control X this real quick, and this should give me the same answer. 6714. Alright, that sounds about right. Because what I can do then as well is do print goal, distance is p1, and this should give me... oh, fudge. Oh no, I can just do, just modify this real quick. Just do, so just do a p if it's in the pipe. Yeah, so this is the field we want. So these are the ones we're gonna have to check. So now actually we just have to find a single one that is within the field, and then we know we're done. So we'll get something like this. And then all I need to do is go to the first coordinate that isn't in here, and then flood it, and then remove anything we find from... Oh, hey, that's actually not too bad, because that might give me every coordinate that I want. Oh, that's so disgusting. Okay, actually, that's better logic. I'm gonna... so this is the logic that we have. Alright, so this is P1, right? So just get P1 working. Alright, so let's go for part 2. So how it's gonna work is we're gonna have... possible, which is gonna be an entire list of every possible value. So this is going to be distances P1. Yeah, whatever. It's not going to matter. So we don't care about the line. And we basically do possible dot... It'll just be a set, I guess. Nah, we'll just make it a list real quick. We can change the type later. Dot append. Actually, yeah, no, that's fine. And then we can just be this, which is just like an if in distances P1. Can we just like block? Alright, let me just like distances P1 this real quick. So it stops giving me errors, because then I can do print possible, and then we can just do exits. What are you complaining about? Statement extended for detent. What? Oh. There we go. So these are all the positions that should be... Oh, if it's not in there... So these are all the coordinates that are even possible to be one. So this is the maximum value it can be. So now what I want to do is, for each of these, basically, can I path find to the end? And so the thing we have to do here is basically have to do adjacencies are not going to be defined there anymore. So you can walk in between pipes, but only when they're pipes like parallel pipes, right? So we need to check if the movement is even legal. I'm just scrolling through the instructions now. By basically saying, okay, if there's two, like... What can you squeeze between? Squeezing between pipes is also allowed. So in this example, if like this, you're allowed to squeeze between, but you're not allowed to squeeze between. So if there is a connection between the two, you can squeeze them. And we already have a way to actually be able to detect that. The fuck are you on about? Oh, because I'm exiting, that's why. Because it goes like, you can never reach this. Yeah, even though it's like right there, like whatever. Right, so P1, no need to bother about it. Alright, so we have all the possible. So now what I can do is I can also do a mnemonics one. So like, it will be something like a known. The reason for this, you can have multiple independent, non-connected fields. So this will be a dict, where basically if we know it's inside or outside, we can mark them in here. The reason why I have to do this is because in theory we could have another like little incision here, like this might go down a bit. And then these would also be like, see, dots up here would also be included, but there would be two separate outside loops. The one way to avoid this is to have an entire ring of dots outside of it, but we would still have the same issue with inside, so it's like, it's completely irrelevant. Alright, so what I do now is while length of possible is above 0. Oh, this is terrible, actually. Alright, so I mean, let me kind of like... yeah, so for P in possible, if P not in known, then we start flood filling. So we basically... start doing this again. So we have our node. So current symbol is going to be this. If we're in between something at the moment, actually we should have like a current pool, a current thing. So it'd be like cur equals a list and then P, because we don't know if we're in or outside yet. So we have a current pool that'll just be P, and this will basically be the distances field, and we have like a current node. So it would be like, say, next nodes equals also P. So while len next nodes, so this will be very similar, over 0. Because if we know what's already in there, we don't care. Because then we've seen it before. It's already accounted for. Also because we will delete. Yeah, so we can just skip it over because then we've seen the entire pool, because I'll be adding that to cur, as it were. All right, so then we go, current symbol is this. And the current coordinate is going to be Oh yeah, and then do for chord in nodes. And then we have the same kind of connectivity stuff. But we have a few extra rules that'll work on as well. Let me just nuke this real quick. No, we need to not forget this line. Nodes. There we go. And then next nodes is just an empty one, right? But wait, what do I do with nodes? That would just be next nodes, right? But no, because we need to make sure that like yeah. Yeah, so we check everything next nodes. We add it on here. I'm gonna go over this logic in a bit and fix it. And then nodes. Yeah, because the next nodes might be empty if there's nothing else, and then it should be 0. So yeah, that's good. All right, this can go away because we already copied this above. And the answer is going to be be the answer, because we'll make known 1 if it's in there. All right, so what do we do? So first we go to the nodes, so that's just always P. Then we check all the adjacent ones, and then we basically see, we first need to, yeah, so we're, say, here. And we get all the quarter adjacencies first, so that's fine. So say we're above, like, this pipe below. That's not true, though. Because the issue is that S has everything, so you're allowed to go anywhere. But, like, you can't... No, because now we're looking at connection. We basically need to see if it's empty. So we're not even going to look at this. We're going to look at the field. But if we're, say, here, we just need to check if it's not in there. which we know by distances. So we basically do... So we don't even care what the current symbol is. So yeah, we go for the next node. So we go, okay, next node needs to not be in distances. So yeah, that's actually correct, because if it is in there, it's obviously already in there. We're gonna bonk, and we don't want that. That's no. Yeah, because the quarter ones will never be in there. Did he implement A star yet? No, but that's basically what I'm gonna be doing. Sort of, not really, because I'm gonna do flood fill basically. I'm sorry, but I'm not gonna check any code, considering I suspect I'll be busy for a little while longer. Right. Do we care about this? No, because we can go out of bounds. So yeah, it needs to not be in there. So if we're on a quarter node, the one is never going to be in there. So let me see. Okay, there's some other crap that I need to do. So if this checks if we're an integer, in which case, this all needs to be true. So if we're an integer, that means we're in one of the dots, and we go to the next one, and it's going to be dots. And if that is a dot, then, you know, if it's not in there, definitely we're allowed to go. Or if we're here, then, you know, we are in between. Then we need to check if the if we could squeeze in between. Oh man, this is horrible, that logic though. So what I would need to take is like a direction, a coordinate, and then I would need to be able to see if we're allowed to go there. So let's do that. Quote that. So we would have a chord, a direction, and we would have our field. And we just do a boolean. Yeah. So we have a... So yeah, we have a next coordinate. And the direction we would then do minus 1j. So we would do like, say... would be next chord plus direction times 1j, and next chord plus direction times negative 1j. And then they need to be in some sort of pairs. Basically, if there are two bars side by side, we're allowed to go through. But if they're top and bottom, we aren't. So I don't need to do some sort of switch there, because we're not allowed to. We're allowed to pass through a few things. So there should be some pairs and some orientations. But there's a lot of pairs. But maybe I can have like some allowed lists. Let me think about that for a second. So, you know, say we have like 2 pipes. See, I don't want to like manually write. I want to prevent manually coding in all of these, because this would sort of be it. So we can go here from the top and the bottom. So that would be 1j and minus 1j. This would be the allowed here. But what I can probably use is only I'll write the ones that are actually allowed, which aren't probably going to be that many. Because you'd have this, you would have there's actually quite a few. Maybe it's better to write what you're not allowed to do. Oh no. So if the connection between the two would be allowed. Yeah. So if the connection between the two we want, the adjacent symbols, then we know we can't go through it. So what we would have to do is we would basically go grab the same logic we have here, which is this line. So return this. And so our direction coordinate would be so we would have, say, yeah, we have a direction. And we need to do just let's do direction times 1j. We need to be careful here because if we do it the wrong way around. So say we go to the right. So then we go minus times 1j means we rotate to the left. So we go from the bottom to the top. So that would be okay, how do we obtain the symbols again? Yeah, it's this. Oh, we can just do curse symbol is U. And next symbol is U. And of course, then we have adjacent 0. No, we can just do it like this. So cur from let's do it like this. F comma T. I need to make sure this is correct. So times 1j is up, no, down. Yeah. So that's where we're going to go from. Yeah. And I think this is the correct way around. What? An illegal target for variable notation? Worst case, I have to reverse this. Why are you not? Because you should be this or allowed. Maybe allowed is not Not a valid keyword? What the fuck? Okay, that works, whatever. Right, so this tells us that we are allowed to actually move in here. Now we don't actually care about the next symbol anymore, because we already do that there. Okay, give me a second actually to think about it. Cheers there, Marvin. See you later. So, say from here, we might want to go to the right. It will tell us, okay, that's not allowed because these two form a connection. Then we want to go down. We encounter a quarter node, and it's fine. And that's it. We don't actually care about the symbol. We just want to record whatever it is. So this means that the next step is a valid one, which we've already determined here. Guess we don't need to care about connections anymore because we're just doing flood fill here. So if next node not in we don't want to modify known. We're going to modify yeah, so cur, because we're going to clear out nodes going to be different all the time. So I definitely want to break here for the first time. Alright, so whatever. So if next node not incur, first of all we do this. We don't care about you. We want to do cur dot append next node. And this allows us to keep track of all of the ones that's cur. And then we just say, so at the end here we can just do a print real quick. But I want to do a special kind of print. So I just do this real quick. Yeah. So we just P1. But here what I want to do, else, let's say, do a 1. If, yeah, I don't care, in cur. Else that. Okay, key error dot. Wait, what? Oh, that makes sense because it might go here and it'll check if it can go between. A dot is Crivens. Oh, if one of them is a dot, you can always go. Hey, this is a disgusting trick. There is just quick and dirty. Index out of range. Because we're not doing the proper checks here anymore. Ah, yeah, of course. We're not, so we're not checking... Of course, if it's out of bounds... of course. So next node is this. So let's make the out of bounds check here, because then we also know what our state is, and that's really useful. Now the state will be like one is inside, 0 is outside. What I can do is if I know that one of them is outside, we set the states and we just don't do anything else. Where did I have that? It's like this, right? Yeah. Because now if we get out of bounds, I do want to know about it. Because then we said state equals 0, because we know we found the outside. Else... and we also... Nope. We also definitely don't need to add anything there. Ah, just one. Alright. What's going on? No. We have an issue. Because... we have like a cropped size. That's kind of what we have. So it's going to be slightly different, but it shouldn't matter a ton. I mean, we're already seeing some issues here. So what's going on here? Alright, let me just... I would just never come here, get here. Wonderful. That's actually not... Alright, oh, yeah, of course. Yeah, right. So what's going on? So you are gonna get called from here, but what's going on? You're 4 plus 8i. Oh, you're not printed uniformly. That's horrible. Where are we? Oh, how about I just very jankily do this after every here. Yeah, there we go. So what's the issue then, my brother? Did you like prints? Oh, how about oh, god damn it. Because we're like slightly different lists we're looking at. Because okay, you're at a dot, fine. Where is it? 4 plus 8.5j. But you shouldn't ever get here if you're not a full integer, right? Because next node, what is next node? Next node. should check here. Next node is 4.5. Okay, so this is definitely true. And oh, so this is just in general, of course. Because we already know about the next node. So of course it calls this. Because it needs to be a float. Oh no, it is a float, so that's actually fine. So what's going on actually? What's going wrong here? So T is 4.9J, 4.8J. Okay, that's correct. But you're 4x9, of course. So you're at the edge. Because I assume that... Yeah, so the Y is out of range, of course. But shouldn't that be caught here? Next node. So what's going on here? True? Why? Okay, what's Len field is 11. Oh, of course, because we're not looking at. Wait. Field is 9. Oh yeah, you're fine, but you are not much. Yeah, whatever. Okay, so it's true. Because Len field is 9. And image next node is 8.5, yeah. Which means the next one, of course, is gonna be... So this is technically... this should fix that. Because now it'll do 8, and this will be 8.5, so now it won't work. Oh, crud. That was not right. Oh yeah, my break. Okay, yeah, so 4.845J, and we only go to 8. Wait a minute. So you are 8.5. Yeah, but this should work, right? Oh, I mean, I probably did this wrong. All right, so 111, 111, 111. Yeah, perfect. Could you, like, tell me the state of this? State is 0, and it starts at state 1. All right, perfect. So what I can then do is here. So now what I want to do is only do it here. Here. This would be when we actually know we finish the block. What we do then is for every coordinate in Kerr, known C equals state. And then what I can do here is remove... Oof. Okay, no. I definitely still want to debug some stuff. Because I want to check... Possible should be very, very long. Yeah, okay. What I want to do now is known will now get all these entered. So what I want to do now is I'm going to move you here. Hate that it does this. And then I want to do else known yeah, and then I remove the break and it breaks. Why? Oh, because it should be known. All zeros. Wonderful. Oh, yeah, because I'm not resetting state. Okay. Now we check the other one. Okay, interesting. So you are not seen as properly outside. So what I want to do there is print goal. Let's just... Right, so what I need to do now is I need to see... where is that function again here? Right, so... Because that doesn't matter. FFTT. Current symbol, next symbol. All right. How do I properly debug this? Conditional should be, so it'll be 0, 1, 2, 3, J. Plus some decimal, so 0, 1, 2, I can do that like here, right? 0, 1, 2, 1, 2, 3, 3.5. I think this is correct. I wonder how slow I am. I probably already am like getting quite a bit late. So do we want no, because we will have. Okay, let me see. Right. All right, let me break here. Dot and a dash, because the direction might be. Minus 0.5J. Why is it minus 0? That's interesting. But I want to go to the bottom, which is minus 0.5J. Dash F? Oh, I'm one too far. Oh. Well, first of all... No, here. I need to redo it now. There we go. Dot dot. What? What's the direction now? Minus 0.5J. Was it? Yeah, because if we go one higher, we go down. So we need to. So it's when it's plus. Bother. What's the direction now? Minus 0.5. That's left, so now it should be 0.5, minus 0.5. Yeah, no. Wait, why does it not? Am I stupid? Does it not go to plus 0.5j? No, it's right there. 0.5? Minus 0.5? 0.5? It's like it doesn't actually go to 0.5j. What? What the fuck? Adjacent is, so here was it the chord. 0.5, 0.5, minus 0.5. And now it's minus 0.5j? And then wait, what? Do we just not go to 0.5j? Am I stupid? What? I am very confused at the moment. Not enough JJ. I don't think I need to encounter more JJ. Feels like it does one twice. Though that's kind of the thing. Minus 0.5? Minus 0.5j. And now it should be, and then it finishes. Maybe this one is where it breaks? No, because it should. Oh, wait a minute. So, of course, next chord, next node should be here. Yeah, so that should always 3.3j, yeah. Yeah, so now. Yeah, because this will occur with different directions. Yeah. So I'm going to go to the right. The direction is, of course, 0.5. Oh, wait a minute. I think it's because the next word is actually going to be in between here, which is one higher, so that should be like 4. 4j, right? Wait, 0, 1, 2, 3, 4. 0, 0.5, 1.5, 2.5, 3.5. Yeah, so 4, 3.5. 4J. 4J. And direction is indeed 0.5J. Perfect. Right, so what happens? So next symbol is dot and dot. What? So 3.4J and 4 plus 4J. So 3 plus 4J is... Well, I mean, of course. So 0, 1, 2, 3, 4... Oh, is that the issue? That we're actually misaligning our fields. No, because the coordinates should still be the same, right? Yeah, so I'm actually counting even 5, 4... Here we go. 0.5J, yes. 7 and F. Perfect. And now we can actually do this checking. Because this should be true. So this should not be true. False, perfect. U. 0. Okay, that's not right. Right, so connections 2, current symbol is 1J and 1. Ah, of course. I see. Yeah, no, because we have the 1 and 0.5 in there. Alright. I get it. So we need to have different ones. Fuck me, no. Okay, so can I normalize this? Times 2? No, because it's like current symbol. So why can't you just be normal? All right. And then if I make this minus 2J, this should be 0. All right. So this move in between is allowed if this equals 0. That's the idea. Because then there's no connection and it should work. Fucking A, man. Yeah, the issue now is that this is only known if... Yeah, let's do K, comma, V in known dot items, and it needs to be integer based. Which will be K and K. Should be something like 4. What? Why is it 13? Just literally count how many times we do this. How is this doing it this way? Because the value should be 1. Ooh, what? Dun 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 dun. Oh, can you just show me known? I can get rid of these. What's known? Why is it erroring out all of a sudden, or whatever? Known. Oh yeah, of course it's gonna have a shit ton of them in there. But you know, some of them should be ones. But we can just do this. Okay, so what are you all about? Two plus 6J, 3 plus 6J. So it should be 0, 1, 2, 3, 4, 5. 5 should be right. No, wait, 0, 1, 2, 0, 1, 2, 3, 4, 5, 6. 2, 3, yeah, because it should be. I think it might be marking these as a 1. But that shouldn't be possible, because it should basically be checking. You know what? Fuck it. There we go, 4. Give me another test example. Please just fucking work. Please just give me 10. Oh. Oh my god. Am I gonna need... That's the same value. Or is it just still busy? It's still working. What? How are you still going? Oh, because there's actually a lot of options. Am I... Oh, there we go. Holy shit. That's the right answer. Fucking A, baby. So it turns out that the spaghetti that I was cooking, it's the fast boiling kind. Oh hell yeah, that makes me so happy, you have no idea. Beaten by 53 seconds. Oh god. I think I already know how I can speed it up a ton. Because in known, what do we record there? Do I also put in my fractional ones there? I'm kind of curious. If I... Alright, so we don't need the field printing anymore. Let's just get rid of that, because I genuinely don't like having this sort of thing here. It's purely for debugging. And then it'll tell me, oh, you're not doing it. Alright, there we go. Yeah, but there's no reason it should be this slow. That's kind of what I'm curious about. And the only reason it can be this slow, because it is exploring a lot of different, like, unless they're all the same. But what I think is going on is that, so my next coordinate, or my, yeah, so where's the plus here? Next node. George, oh god. So what I'm kind of curious about is, like, do I do my mnemonics properly? Because we only skip P if it's not in known, but known should have it could genuinely be that complex, because, you know, I don't even fucking know. Because this pipe is all part of our network, but for this one, it might have to check a ton of different locations, you know. But if they're connected, it should instantly mark everything. Replace every pixel. Yeah, that's what I was thinking. I mean, that's technically what I did. I was thinking about, like, actually replacing it. But hey, it works! Also, you're not replacing every pixel with a 3x3 pixel, because then you would turn a 3x3 grid into a 27x27 grid, even though in reality it's only a 9x9 grid. So, because you're scaling it by a factor of 2 squared, not 3 squared. So, sorry, Hamster, but it's a 2x2 pixel. Not that it really matters that much. Now, what I'm curious about is, No, I don't. Because I add every half corner. So I turn every pixel into, I add the intermediate bits. Because I have 0, 0.1. So sorry, 0, 0.51. Actually, did I? No, maybe. Are you right? No. No, because it turns 0, 0.51, and then I don't turn, like, I don't recreate the 1. Could you? I don't think you can. Because you'd have to do, like, line indexing. You can? Wait, am I stupid? But how would you be able to figure out if... Super easy. Show me an example. How many vertical pipes are to the left? But no, you're right, Hamster. I think... But there's overlap. I don't think I'm gonna... Well, I'll take a look at Hamster's code. That's the only one. I think I've got enough brain damage for tonight. You can squeeze through and don't count. While Natural's making me want to shoot myself, I decided to steal one more thing from Reddit. Behold, my shoelaces. No, because I'm trying to find the link have to. Why did you not post the actual link in my Discord? Now I have to like type it over. I don't want to do that. Did you? No, you like just. Oh no, wait. This is the image. Why would I want to do that? Here. This better be an actual picture of your shoelaces. Okay, what the fuck is this shit? Self-overlapping polygons, so they won't be self-overlapping. Okay, so yeah, you've got Cartesian coordinates. Yeah, so here this is but what is loop? What is loop here? Just all the coordinates of the loop? Oh, that's all the Cartesian coordinates of the loop. Yeah, I see. Because you're like doing... What? This is disgustingly simple. Wait, inside area divided by 2 minus the length of the loop divided by 2. What the fuck? Pick's theorem. Entry points on its boundary and in its boundary. Oh, jeez. Okay, so this is like, I don't get this. I hate it. Shoelace theorem. Is there like something that actually helps explain this? So what did you use actually, the trapezoid formula? No, you did. No, x times y. The Jordan curve. I think I've heard of that before. So the idea is that any vertex, sorry, any edge that's like negative or positive. But why are there positive or negative edges? The sign of AI. Oh, because... Yeah. Because you go up. Oh, because you go up in one, but backwards in the... No, wait, no. You go forward in both. Backwards in Y, but backwards in X. Oh yeah, forward in both, backwards in both. But there's also forward in both. What? Trapezoid picture. This one. And which one do you mean then? Above the previous one. Oh, you mean this one? Oh, like that. What the fuck? Oh no, I see. Bottom edge or like top edge, as it were. Yeah, okay, I see. And this is what you meant with counting left right, because here these two cancel each other out and you have a -1. And here, you know, one -1, one -1, a -1, yeah. So I just need to reduce. We already have that, so yeah. Oh, Jesus Christ. This is clever, but... yeah, so you do... on 1631. Oh, this is... I'm not a mathematician, damn it. But I guess this is also why this is the good old, huh, you can solve this in this shitty computer in half a second, because of course, yeah, I saw the Hilbert curve thing from Nix as well. I love that solution, and mine is, I mean, mine is shitty as fuck. No, I know you saw this from Reddit, but this is like, it to me, it gives me kind of the same feeling as the Chinese remainder theorem. It's like, yeah, but Pick's theorem is just the breakdown I had in comments. No, I'm gonna read that in a second. But wait. So for Pick's theorem, because this assumes a convex shape. Jordan curve. Which one is that again? Yeah, but Pick's theorem only needs integer coordinates. True. This is just any shape. But does this work for... yeah. Here you go. With a star. Yeah, here, but like... oh, wait, no, you're right. This is a concave hull. Is that the right term? You know what I mean. Okay. Yeah, so I'm thinking about how this makes sense, but the thing for me is that because you only move on cardinal directions, it just doesn't compute that much in my mind. But yeah, so that's they're all the same to me. All right, I'm just gonna accept there's far more clever solutions than I did. How much lines of code did I have in the end, by the way? Just for reference, I had 102 lines of code in the end. How many could I have cut out? I can cut out this one. I'll reformat the file. That's part 1. 101 lines of code. Surprise tool that will help us later. I'm not sure I like that. Alright, so how do you do your loop? So loops just start as whatever. Yeah. It's what I, the better way of doing it. Yeah, so previous... What's the next move? Yeah, because it's the last entry. 0 and 1, this is X and Y. Loop is the whole loop, so... Wait, what? If len grid... Lines is just all your input, yeah. 8 over Y. This means just the Y coordinate is in bounds. Oh, because... Yeah, no, I see the logic. Because if you're going in the Y direction, these are the only ones that will ever be valid. Because then this won't be true at all. So then you fall back to the next one, yeah. But how do you make sure someone might not go from, say, 7 to... What's your previous ones? This is the next one? Current position is, say this, the next one is yeah, then you go up. Yeah, no, I see. Yeah. I just like you call it I and J here and X and Y here. If next loop equals BR. Oh, that's you're done. It's like break basically, yeah. And then you just divide it over 2, just fine. Could have done the same, but whatever. Max value also works. Done once you get to Brazil, fair point. It's a clean part 1. I like it. My part 1 was... I mean, I wrote my part 1 in the assumption that we might be doing something more complex, like slightly different adjacency rules. Which would have worked pretty well, but you are... I mean... Yeah. You assumed a simpler version, which worked out perfectly fine. So what is this? Lines, tile. For every tile in your loop. Wait, what the? What the hell are you doing here? Oh, loop symbols to asterisks. I see, yeah, line... You get all your X and Y's. No, you can't, because you can't modify strings in place. Ah, this is... Now you know you're cooking with Python when you have to set your recursion limits. So now you go over every single position in your loop. If it doesn't equal star and not an outside. Yeah, because I was wondering how you catch that. With this, because you don't actually seem to do any subfractional checking. So this just doesn't work. You just, yeah, I see that here. So I was curious because I was trying to find way this work, but this won't work because this is just simple checking. Then you do polygon. This is disgusting. This would work if I made the grid 3x3. 3, but it's 3, 8, 1. Nice. Okay, so you cheated using Shapely. Yeah, because of course it has no notion of No, so this wouldn't work if you just made the grid 3x3. You would have to then also check if the extra points you generate would contain a wall or not. So, I mean, I guess you could. So yeah, fine. Yeah. So it would work if it's 3x3. You'd have to do more logic, though. So what do you do here? It would open the way to the enclosed parts. Oh, because it doesn't consider... But... Oh, I see. Because it does it... Because the pathfinding can, like... Because you just... Oh, because it's No, I see. No, I know what you mean. Because your lines are on Cartesian coordinates, but of course, in between there's still nothing. So no, you're right. It does open the way. You're correct. Okay, this you could have actually just made a list comprehension. So what is this? Inside tiles. What is inside tiles? So that's your shitty not working version. For vertical count slash S0. Yeah, it's just count if it's even or odd. I hate this solution. I love this one because it's actually pretty cool, and I never would have thought of this. This one feels wacky. This one's just cheating. This is literally it's just import solution. Inside tiles, because now it had all the correct tiles in it. Yeah. So like you pick an inside and an outside, and whichever doesn't reach the boundary is inside. Yeah, exactly. That's the one that I was thinking about as well. Like doing, like marking in and outside beforehand, and then just discard one of the two at the end. I wonder if you can solve this one using, if you can solve this one using paint. Just do a flood fill. What the hell did you do, Jack? Okay. Diagram? Ah, switches. Love it. What the fuck are you doing here? Hey, whatever. What I'm curious about your part. The part one is not interesting. It feels like you're just repeating this part over and over again. Jesus Christ, what the fuck is there again? I was like, where the fuck's your part two? Yeah, it just keeps just like up, right, down, left, but like, ugh. This fucking or statement is what awful. If wait, what the fuck's the logic here? What? What the S is supposed to be? Oh, I see. Yeah, okay, here's the actual, like, logic. Fair. Okay, I see. Oh, you just keep track of your inside or outside the loop. Yeah. So, you start outside, you enter it if you cross a line segment that is in there. Yeah, okay, I see. I think that's actually the... Because I'm just that good. I don't know what idea did you have first. That said, I'm not gonna spend too much more time. Like, I'm pretty tired as well. Oh yeah, my time on day night was pathetic. Fucking 17 minutes. Jesus Christ, it was awful. I had the right idea. Just no, I had the wrong idea. Failed at executing it. Then realized what I should have done, and then failed at actually implementing that for a while, which is just perfect. No, I did not take a look at your Codex. I also probably won't because I'm too tired and I went through 3 days. Don't have the time to actually go through all the code for everyone. I'm like probably actually gonna go to bed soon because I've got an actual course tomorrow. Like I've got a fucking workshop whole week. I need to start at 9. Jesus Christ, it's horrible. All the corner pieces and consider any corner ground enclosed and spread it from there. It didn't work. Find the corner, look at the outside and consider it poisoned. All ground that is not poisoned is enclosed. Maybe it doesn't work. You could. I've finished. I did. I beat everyone's ass in day 10, which is the one that matters because it was the more difficult one. Like being good at something easy, that's not impressive. But being good at something difficult, now that's impressive. That pops me right back to number 1. I probably like did something else in between. I can't imagine he didn't actually spend 7 hours working on it. He probably had to go work or something. Marvin had the same some other day. Like that's the one downside of what's not really reflected in the delta, and also why I look at delta times and not at like part 1 time, because like yes, I'm the fastest for day 8 because again I'm just that good, but I also I couldn't do it until today, even though this was Friday. You beat me by middle on day 10. Don't get ahead of yourself. Yeah, I beat you with better. Well, is it truly beating you if you finish by such a horrible code? Glad to see H has humbled you. I like how both you and someone else mentioned me that at the exact same time. Yeah, no, I agree, Hamster. I would love for that to see that as well. But we just don't have the technology. I mean, for me, you have the streams, so in theory, you could go back and like actually work it out. But I also intentionally tried to not read the prompt before I start. It's beautiful code. Javas, because I'm better if I think I'm better at part 1 because I just if it together. Didn't even generate my input until my tests are done, so it won't really work. No, but they could in theory have a cookie that just shows when you first open the page. Like that shouldn't be very difficult. I agree with input generation doesn't work, but just look at when you first open the page. Again, not very practical, because then you could just open it on one computer. Yeah, open it on your phone in theory and not being logged in. But yeah, it's not gonna happen. But I'm still very happy that I'm actually at the top at this leaderboard. I didn't expect that. If I hadn't screwed up day 9, I could have been ahead by even more. That said, still plenty of time to slip. No, exactly, Jack. I mean, that's why, someone else give you day 2. Yeah, but you could... You know how you can also cheat? Just grabbing people's code online. Got bronze for part 2, day 10. I got 1 silver medal, and I'm happy with that. It's a downside of not living, or not waking up that early. Anyway, yeah, very happy with how that all worked out. I also see that I need to poke some people doing more advent of code. I know has to move soon, so he probably won't actually have time. Sorry, do the reverse example. Shrinking breaks the test while expanding unbreak it. Then just fill it. Oh, this is what I did, basically. Yeah. So I think we kind of had the same idea. But instead of expanding the grid... okay, so expanding the grid would have been better. Because it would have made adjacency rules easier. Sort of easier. Because I didn't do a 3x3 expansion. Because I basically keep whatever character would be here. I check if this should be a pipe that actually makes a connection or one that doesn't. If it's in the loop. Wait. Yeah. Because if there's like, say... Yeah. So I don't do a 3x3 expansion. But that will work. I do the rendering code. Let me actually show that image because it did look kind of nice. Can I find that again? Here we go. Good old Hilbert curves. So this is the distance from the start, which I think is there. You can see the central area is enclosed. It would have been kind of funny if it wasn't. But this also shows you why my algorithm is so slow. Because there's probably a lot of like ingresses into this. And I do a lot of checking I really don't need to. Oh, I saw this one before. I didn't think this was actually the problem. Nice. Anything else? I'm gonna probably call it in a second here. It's kind of see Fusion in my Discord. It's kind of funny knowing part 2 and watching Nitro write something that makes it harder for himself down the line. I am like 50-50 on that. I think that this solution I very much like, because I think checking using imaginary numbers to basically handle directions changes like this, I think is very clean. I genuinely very much like it. It is, though, very convoluted and difficult to keep track of in your mind. I should also simplify this, because this is just return equals 0. Whoop. Mages will be cleaner, extended 3D better. I mean, I agree. Oh yes, no, to 3D, hell yeah. But I don't think, have they done a problem where they go to 3D before? I know we've done a 4D day. Before that was fun. That was really fucky to keep track of in your mind. Good grief. But I quite enjoy this because rotations worked. What probably would have been best, what I think in hindsight would have been easier, would have been to kind of keep. No, it's not 20 seconds. It's like 54. If you have like a sort of an actual character moving around, this is very, very much superior. Here, I think it's a bit 50-50. The way that I implemented it, it's better because I implemented it that way. So, of course, it's going to be better. Well, that sounds a bit crude, but like being able to check if you're allowed to move in between something in this way, I think is really, really neat. Because you can rotate your directions around super easily. Because I don't have to like go with like an array that keeps track of like if it's this starting position in this direction, I need to do these two deltas, stuff like that, you know. It ain't bad. Anyway. I'm gonna go call it because I'm just for fucking 4 hours, Jesus Christ. I need to go to bed. God damn it. That's disgusting. I like my solution, it's just clunkily implemented. This is disgusting. Anyway, I'm gonna call it here. Good night. It's not super likely I'll be there tomorrow morning. We'll see if I actually wake up in time or just decide to sleep more. Anyway, cheers.